Okay, let's look real quickly at when we have polynomials that are taken to exponents like this. What does that mean? It means the exact same thing as any other exponent would mean, right? If I have 5 squared, that means that I have 5 times 5 is 25. So in this case, we have x plus 10 times x plus 10, x plus 10 times x plus 10. For this reason, we know that we have to distribute, whether that's through the area model or just using the distributive property. We know we have to distribute. You have to resist the urge to take this exponent and bring it all the way through. This is a mistake that people make all the time by saying that x plus 10 squared is x squared plus 10 squared, which would be x squared plus 100. That is incorrect. That is not right. Why? Let's look at some numbers. Let's just say let's use 3 plus 2 squared. 3 plus 2 squared. Well, we know if we're using our order of operations, we know 3 plus 2, the parentheses first, that's 5 squared, and 5 squared is 25, right? So we should get 25 if we were to do that. If you were to take this exponent and bring it through like that, 3 squared plus 2 squared, that's 9 plus 4 is 13. You can see that that is not the same. But we do know that we can distribute those, right? 3 plus 2 times 3 plus 2 would have to be 3 times 3 is 9, 3 times 2 is 6, 2 times 3, 6 again, and 2 times 2 is 4. So we have 9 plus 6 is 15, plus 6 is 21, plus 4 is 25. And that works. We know 5 squared is 25. So you see we have to distribute to do that, right? So it's the same thing here when we're trying to work this out. X plus 10 times x plus 10, we're going to distribute that. You can use the area model like this if you want, or you can just distribute, right? X times x is x squared, x times 10 is 10x, 10 times x is 10x, and 10 times 10 is 100. So you can get x squared plus 20x plus 100. Either way you want to do it, distributive or area model. What about when there's more than one, though? This is an interesting case here. 2x minus 4 cubed. That means there's 3 of them, right? 2x minus 4, 2x minus 4, 2x minus 4. Well, ask yourself what you would do if these were just numbers. If I asked you to do 3 times 2 times 5, what would you do? Well, we could just multiply 3 times 2 is 6, and then 6 times 5 is 30, right? So you can do the first two and then the next. Really, you could do this in any order you want, right? 2 times 5 is 10, and 10 times 3 is 30, same thing. 5 times 3 is 15, and 15 times 2 is 30. It doesn't matter. It's commutative. It's multiplication. Do it in any order you want. But the main idea out of that is that we're going to have to multiply 2 of them first and then the next one. So in this case, 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. And then negative 4 times 2x is negative 8x again. Negative 4 times negative 4 is positive 16. So that will be 4x squared minus 16x plus 16. And that's still multiplying the original 2x minus 4, right? So we multiplied these two to get this. We still have to multiply by it one more time. Let's do this one with the area model. So we put these guys right on top, these guys on the side, and we're just going to multiply them through 2x times 4x squared. 2x times 4x squared is 8x cubed. 2x times negative 16, that's negative 32. X times x is x squared. 2 times 16, 32x. This guy here. 4 times negative 4, negative 16. x squared, negative 16 times negative 4, what is that? Positive 64x, and negative 4 times positive 16 will be a negative 64. That gives us 8x cubed, and then these guys, negative 16 and negative 32, that's negative 48x squared. 64 and 32, that is a positive 96x, and negative 64 when we're combining like terms. So there we go. Combined all those like terms, that is our final answer. So what we did here, we said there's 3 of them. We're going to multiply the first 2 and then take whatever we get and multiply the next one. You would do that for however many you have, right? If I had 6, multiply the first 2, take that, multiply times the next one, take that, multiply times the next one, take that, multiply times the next one, just like you would with numbers, except we're doing it with polynomials now.